All right, guys, this is a follow-up video on my previous video on the quantum mechanical setup, just to give you a bit of a theoretical background. Now, what I showed you was something called the double slit experiment here in figure A. This was originally conducted by someone called Thomas Young in 1801, and this really started the whole quantum mechanical revolution. It wasn't until the early 1900s that they really took it serious. It challenged, obviously, Newtonian mechanics, and it challenged, in the early 1900s, Einstein's relativity. So everyone thought everything obeyed by classical physical materialistic laws. And if that was the case, when you shone a light, it should behave as particles, as point particles. So if you've got a double slit, which basically an aperture with two holes in it, it should cast two clear beams like this, but it doesn't. What it does, it creates an interference pattern. Now this demonstrates that light is a waveform. It passes through both slits in superposition. It's undecided. Doesn't know whether it's going through slit 1 or slit 2, so it kind of goes through both of them. And then it interferes with itself, creating this interference pattern. That is the classic Young's double slit experiment. Now you can have a situation when it behaves more like a particle, and that's when you observe it. Now in physics they call this the observer problem. And we're going to get into a whole range of different theories that explain this particular problem and how it relates to my own work. But right now, think of this as a waveform, and as soon as it's kind of measured by some kind of measuring device, all of a sudden it behaves like particles and forms two clear beams. There's additional experiments that we won't get into right now. Basically, retrocausality type experiments. There's really spooky kind of actions where you can create a which-way path, and then you can delete this through this random configuration, and it loses the which-way information, and then that has kind of retrocausal or supposed retrocausal effects then later. We'll get into this in more detail because it gets really, really complicated. So I'm going to go through all the different types of experiments. But I hope that gives you a kind of nice little guide about what the quantum mechanics, how it all started. And it really kind of spun physics on its head, because all of a sudden it was a challenge to the materialistic view of point particles, and now you had this thing where everything was weird and what Einstein called spooky, and he didn't like it, and he worked, even though he was one of the early developers of the theory, in something called the photoelectric effect in 1905. He then, in his later life, kind of worked against this, and we'll go through the relevant papers with that at a later time. But that's the very, very early kind of basic intuition behind the quantum mechanical experiment. So I hope I've made that very, very clear. Okay, thanks, and I'll catch you again.